Let us now try to define and understand what exactly is an algorithm. An algorithm is a problem solving approach. It is not necessarily used to solve problems using computers. It can be used to solve any real life problem. So, an algorithm may be defined as a step by step, finite and ordered sequence of directions or instructions used to solve a well defined problem. Let's understand what are the keywords here. The first thing it says is, in order to solve a problem, you should be giving step by step guidance. The number of steps should be finite. That means the problem should be solvable in a finite amount of time or using a finite number of steps. That means it must have a solution. It cannot be an endless solution. The order of the steps is very important. Which steps comes before which step is very critical. And most importantly, the problem must be well defined. If I tell you, go there, I'm not telling you where to go. You can't solve a problem. But if I tell you, go to the market and get me tooth powder, toothpaste, and washing soap, this is a clear, well defined problem. If I say, go to the market, that's not a well defined problem. The problem should be well defined. In order to understand an algorithm, we will take a look at a very simple example to make tea, and then I'll explain algorithm in much more detail. Let us say you invite me to your house, or I invite you to my house, and I'm required to make 2 cups of tea so that we all enjoy having 2 cups of tea. So let us see the number of steps in order to make tea and serve it to both of us so that we can enjoy the cup of tea. So what I do is, I first instruction I say is, take a medium size vessel. That means take a medium size vessel which you can put water on that. Next, measure 1.5 cups of water and pour it into this particular teapot or tea vessel. Third step, place the vessel on the gas burner or the electric heater and switch on the burner to medium flame. Very clear instruction. Put it on the gas burner and switch on and put it on to medium flame. What do I do next? I am then saying add 2 spoons of tea powder immediately. You can add even 3 spoons if you want to make the tea much strong. Next step, let's see what is this next step. Once the water begins to boil, after you have put the tea powder, add sugar. So you may add 1 or 2 spoons of sugar based on your taste and requirements. After a minute, go ahead and add milk as per your requirement of taste. Then number 7, in another minute, after it boils a little bit more, take the content of the vessel and take 2 cups and pour the tea after passing it through a strainer. Strainer is your jali which is used to filter the tea powder. Then serve the hot tea to the person. So if you look at it here, to make tea, I have followed the first rule. It's a step by step instruction. Is it finite? Yeah, at the end of 8th step, I am able to drink tea. Is the sequence well ordered? Absolutely, it is well ordered. Because if I had said, step 1, take a medium sized vessel, add 2 teaspoons in step 2, okay, start the burner as step 3, then the tea powder would have burnt off. That is not the correct order of the sequence. So I am again using a ordered sequence. What is a well defined problem? The well defined problem is, you need to make 2 cups of tea for me and you. So here if you see, it's a perfect step by step way to make tea. Does it have finite number of steps? 8 is the finite number of steps. Is the sequence proper? Absolutely, sequence is proper. Otherwise, if you take a vessel, put on the burner and directly add sugar, the vessel will turn black because the sugar gets converted into carbon, and it is also a well defined problem. Now let's try to see what are the characteristics of the algorithmic approach. The characteristics of algorithmic approach, or a well-defined algorithm or approach to solving a problem, is characterized by a few basic steps or few basic requirements. First, the algorithm should have 0 or more well-defined inputs. What are the well-defined inputs here: water, sugar, tea. Okay, these are all powder, all examples of well-defined inputs. Now, what now is each instruction crystal clear? Absolutely, each instruction is crystal clear. If I had simply said take water and pour into the vessel, that would not be an example of a clear instruction, because you do not know how many cups of water to pour. So each step should be definite and not ambiguous. It should not be left to the your wish. It should be absolutely clear. Next, each step should be feasible. That means it should be possible. Okay, you cannot give an instruction which is not possible to implement. Each step should be feasible, effective, and doable. Then, after following the steps, it should lead to the solution of a problem. It cannot be a problem in which there is no solution exists. That is not an algorithm. And finally, algorithm must produce one or more output. What is the output we're getting? We're getting T here. So this algorithmic approach has these following 5 characteristics in order to solve a problem. Even if you take area of a triangle by the symbol formula half base into height, what is the input? Base and height. What is the definite instruction? Area is half base into height. My area is calculated. Is it a finite step? Is it doable? Absolutely. Does it terminate? Does it find the area? Absolutely. Does it produce output? Absolutely, it is producing the area as the output. So you will understand a lot more about this theoretical description of algorithm once we try to do a number of problems. But for now, just understand that it's a well-defined sequence having a finite number of steps solving a well-defined problem. So in characteristics of this algorithm are a must in order to find solution to a problem. So if a problem requires solution using the algorithmic approach, you should see that it possesses each of these characteristics.